Paper ID 321. Mr. Naimur Rahman Khan Sifat.
So maybe absent. Okay.
Okay, we are dropping it out.
Mhm.
Paper ID
Paper ID
365.
365. Deep learning based soil quality prediction framework for sustainable agriculture in Bangladesh. Are you present here?
Yes, sir. I present.
Who will be presenting the paper?
Yes, sir.
Can you please introduce yourself? Is it Mr. Rula?
No, Istiak.
Hello, everyone. My name is Istiakul Hassan, Department of Tripoli, University of Liberal Arts, Bangladesh. Today, I prediction framework for sustainable agriculture in Bangladesh. This is my outline, abstract introduction, methodology, result and discussion, conclusion, and finally reference. Abstract. Agriculture contribute agriculture contribute 12.7% of GDP and employs 48% of the Bangladesh workforce. We are approach the overcropping and imbalanced fertilizer use, and also propose the deep learning based soil quality prediction DLSQP framework for fertility classification. Slow and costly. So AI এবং deep learning can improve prediction accuracy and decision making. Some objects are evaluate soil quality across the agroecological zone, generate a district level soil quality reports, and recommended balanced fertilizer application. There are related or earlier method.
To answer the question.
Yes, sir.
Okay, from the audience, I request the audience to ask questions if I have any in this research topic.
Thank you. This is a good research topic, that is based soil quality prediction framework for sustainable agriculture in Bangladesh. Actually, I want to know about the motivation of this research.
Our motivation is that farming is the important of Bangladesh. So we are create a zone, 30 zone. So then we are soil testing and all our ecosystem zone are create. So this purpose we are trying to.
Is there any state of the art comparison?
No, sir. Only Bangladesh perspective and different types of zone. Only 3 zones are compared.
That means this is a very new work.
Yes, sir.
That means you are the pioneer.
Sorry, sir.
You are the pioneer.
Yes, sir.
Oh. In your paper, we see 5 feature for classification.
Yes, sir.
Use 5 or 7?
Sir, 5.
5 feature. Only 5 feature.
Sir, accurately 5 feature also.
But the structure of DNNR, we see here 7 maybe. Yeah, 7. NPK, pH, moisture,
In
climate
your presentation, you
factors.
also mentioned 7 features. I saw it.
Yeah, but in here we see this.
Using Google Earth Engine and machine learning. Mr. Shahriar Hussain, are you present here now for attending the question and answer session? Anybody is present on behalf of him? Okay, we'll move forward to the next one. Paper ID. Paper ID 180.
Yes, sir. Yes, sir. I'm here.
Who will be presenting? Mr.
No, no, sir. Can I present? I want to present.
Uh, just give us a moment, please.
Yes, sir. Sure. I want to share, sir, from my side.
Paper ID number
180.
180. Bridging code, right?
Yeah, bridging code,
And
sir.
comprehension.
Yeah, sir.
A comparative analysis of transformer models for Java
Java.
source code summarization.
Yes, sir.
Okay, you may start now.
Yes, sir. Thank you, sir. Just give me a minute. Can you see my screen? Hello.
Hello.
Yes, sir. Can you see my screen? I'm visible.
No, it is not visible to us yet. Oh, sorry. Okay, we can see you now.
Yeah. Thank you, sir. Good afternoon, everyone, and respected. Sorry, sir. Give good afternoon, everyone. Respected chair, reviewers, and my fellow researcher. My name is Shahriar Sadman. I am from East West Dhaka. Today, I am presenting our paper
Excuse
ID.
me,
Yes, sir.
Could you please introduce yourself again?
My name is Shahriar Sadman Dihan.
Okay.
Yes, sir. I'm the first author of this paper. I'm from East West University, Dhaka. Today, I'm presenting the paper ID 180, titled Bridging Code and Comprehension, a comparative analysis of transformer model for Java source code summarization. These are my model have already shown strong performance in the field like natural language processing and the computer vision. Our dataset containing 18,000 Java dataset sample that we collected from the Hugging Face, the secondary collection. But before training, we have applied several pre-processing steps like including text cleaning, tokenization, and sentence length normalization. And we split the data to ensure the consistency during the model training. Our main goal is the work of to fine-tune this model to achieve a optimal summarization performance tailored specifically for Java source code. For the research background, the code summarization is becoming nowadays, it's a very important thing for the software engineering to understand the codes. It automatically generates the short human readable description of what a piece of code does. It is dramatically reduce the time for the developer to spend understanding the legacy or the unfamiliar code. Java is particularly challenging because of its verbose syntax, strong object-oriented nature like classes, inheritance, interfaces, etc. All this make a accurate summarization very hard. Just like early diagnosis to save lives in medicine, early code understanding through a good summary speed up the debugging and the refactoring and the maintenance. Our goal is very clear here. Compare popular transformer model to find out which one is the best to understand the Java codes. These are the related works we have looking for the several strong work already exist, but we use the different method. Like you can see the automatic source code summarization, but they use the method like called the graph analysis using the 19,000 plus Java methods like seek open source Java programs. And there is another one like the automatic generated commit. They use the commit message generation from genset. It calculated 62% performed of 84% content adequate and 50 commit and 6 project. The another one is that improved source summarization via graph neural network. They use the convgnn for the AST, and it gained 11.70% result. And the last one is retrieval based neural network, that I use the systematic and symmetric retrieval function of 20.7%. They use 180K of Python pairs and other ones. But for Java code summarization, in 2025, we use like a different approach to handle this thing. Like very few people actually directly compare this using the BART GPT-25, this kind of sentence transformer. Sorry, the research question that we faced here is how effectively can this transformer model generate the accurate and the meaningful summaries of the Java code? What are the comparative strengths and the weakness of this transformer model to summarizing a Java code of this according to its complicated class, methods, and inheritance, etc. How does the tokenizer choose the word piece for the BERT, BBT2 for the GPT2, the sentence piece for the T5? How it impact the performance of the models? Can the fine-tuning transformer model on the Java specific dataset improve the context and the semantic accuracy of the summaries? Or which evaluation metrics that we used, BLU, ROJ, and Meteor, or we also use here human evaluation, which one best capture the quality and also the summarization that produced by the transformer model of the Java codes, and what extent do the transformer model enhance the developer comprehension to do the productivity in the real world for the developers? Our objective is very clear: to use the BART GPT-25 for the Java summarization, use both automation metrics and the human evaluation to get exactly what the performance or what the summarization is, the fine-tuning the both model on Java specific data, and also understand how accurate summarization can boost up the real-world developer productivity. This is the methodology we followed. We have already mentioned we have collected the data, and after collection we have doing some pre-processing, then the model training and evaluation. For the processing, we use the text cleaning, we use the tokenization method, the normalization, data is splitting into 10, 80, 10, and 10. For the 80, we use the training, for 10 for the validation, and test for 10% for the testing. Then you use the model training using the T5, BERT, and GPT-2. We also use the AdamW optimizer. We also here who is using the AdamW. For the model evaluation, we use the BLU, ROJ, Meteor, which is good for the NLP task, and we also added here the human evaluation, where we particularly use the human to understand the summary, which one give you the best, and for the then we do the result analysis. But this was surprising because T5 usually here we can see that in the data sampling, you can see that you use the 1800 data from the Hugging Face here. And another thing here is using some of the real example. All you can see in the data sampling here, we use the model, combining some of the best perform model, and we want to apply the model comprehension on the practical deployment, and we also want to increase the number of data set to achieve more success. Thank you.
Thank you for the presentation. Are there any questions from the audience? Dihan, did you try GPT-3?
No, sir. Because the lack of the small data set, and because of the lack of the hardware, we want to enhance our device performance, and then we want to use or try different kind of models so that we acquire more performance. Because you can understand, a Java code, a large number of Java code and their summaries, it become a huge for a huge data set to train us. So when we still collecting, or we still want to manage a big data set, like a combining of different language data set like Java, Python, and then we want to use the other powerful models like you mentioned, GPT-3 or the upcoming some other transformer models, then updating our hardware so that we can train it.
Did you observe the evaluation time in your three models, what you proposed here?
Yeah, it takes actually a lot of time. I think because of our low hardware, it's time it takes around 8 hours for us to train and to get the performance. Yes, we use a lot. We improve the epoch number, so that's why it takes that much time. But I think if we update our hardwares and also improve, do some cleaning, do some more improvement in the data set, it will take a short time than it will take earlier.
In your program, you show some common problems. Did you apply any hallucinated data to test the model?
Yeah, we have tried that, but it's also an issue because the hallucination is nowadays a big problem here. But it's perform well for the bird, but the T5 is lacking because we have already seen that T5 is already the third best perform model here among the three. But the bird is always perform well because it's a bidirectional